Alright, viewers, my name is Sam Maxim by the grace of God. Now, I'll be talking about implicit differentiation. You see, when y is distinct from x, if you have a function like this, you have x squared minus 4, for instance. This function is called an explicit function because y is separate from x. You can see this y, this x, so they are separate, so they are distinct. So it is called an explicit function. Explicit. Of course, we can differentiate this at ease. We can either go by our basic differentiation where this will multiply, subtract one, this multiply, or sometimes when it is complex like this, we can use our quotient rule to solve. But there is another function that is called implicit function. That function is a function where y and x are intertwined, they are joined together. If you have this, for instance, if you have that, you can see that y joined to x, y joined equal to 20. So this type of function is what we call implicit function. And the method we use to solve it is called implicit differentiation. Of course, we must understand the fact that this is x cubed times y squared. So it means they are multiplied. X times y squared, they are multiplied, they also multiply. So you must use the product rule to differentiate these terms singly, and then you now get your dy dx. But take note, anytime you differentiate y or y squared, whatever, you times it by dy dx. That is the basic rule for implicit differentiation. Okay, now if we are about solving this, alright, if we solve this now, remember our product rule says that dy dx equal to v du over dx plus u dv over dx. So now we have to address each of these terms separately. So we'll call this our u, call this our v, call this our u, call this our v, call this our u, call this our v, and then we solve, and it will make life very easy. Now, following this rule here, for this v, viewers, you can see v is what? Y squared. So you put a y squared times du dx from here. If you find the derivative of s cubed, you will get 3s squared. This will come and multiply the function, then you subtract 1 from the power, you have 3s squared. You have a plus sign, viewers. So plus u is what? U from here is s cubed. You have s cubed times dv dx. V is this. So if you differentiate y squared, you have 2y. But remember I said when you differentiate y, you multiply by dy dx. We are done with this. So go to the next one, plus. For this, you are still using this rule. V is what? V is y squared times du dx. If you differentiate x, you get 1. Plus u is what? U is x times, if you differentiate dv dx, which is this, you get 2y, but you multiply by dy dx. We are done with this. We move to this. For this, following this, v is what? V is y. So from here, viewers, we have y times du dx. From here is what? If you differentiate u, yeah, you have 1. Plus your u is what from here? Your u is x, viewers. X times dv dx. Your v, if you differentiate y, you get 1. But instead of putting 1 dy dx, just put dy dx equal to, of course, the derivative of any constant is 0, so this becomes 0. So now at this point, you will now take like terms. Y squared times 3xy, you have 3x squared y squared. in order of magnitude. 3x squared y squared plus x cubed times 2y, you have 2x cubed y dy dx from here, plus then if you come to your y squared times 1 is y squared plus x times 2y, you have 2xy dy dx plus we move to this side, y times 1 is y plus x times dy dx, you have x dy dx equal to 0, which is this. Alright, so now anyone that don't have dy dx should cross to the other side. So if you look very well, this does not have dy dx. This does not have dy dx. This does not have dy dx. So these ones I mark will cross so that you can take like terms for dy dx. So if this crosses, so you now have from here, you now have taking that, you now have 2x cubed y dy dx. That's 1 dy dx. The next dy dx is this. But take note, there is a plus sign, so plus 2xy dy dx. So you have taking this and this, so it's remaining plus x dy dx. So you have plus x dy dx. I believe that is all for dy dx. So now those that don't have dy dx will cross to the other side. Take note there's an equal to sign. So if take note that this plus, when it crosses it becomes minus. When this crosses it becomes minus y squared. This crosses become minus y. So we have this plus, we have minus 3x squared y squared from here. That's crossed to become minus, viewers. Y squared crosses become minus y squared. And then this crosses become minus y. So I believe we have taken item. Now we'll take out dy dx. 1, 2, 3 will come out because we are looking for dy dx. So if that's the case, if I take out my dy dx, I will impute 2x cubed y plus 2xy plus x, because if dy times everything, you should go back to this, equal to minus 3x squared y squared minus y squared minus y. Of course, you are looking for dy dx. You divide both sides by all this over this 2x cubed y plus 2xy plus x, viewers, equal to, okay, this will be over 2x cubed y plus 2xy plus x. So of course this will cancel this. You have your dy dx to be equal to this. Now if you look very well, you have x common there. You have x common, x squared y. So what will happen is this. If you factorize this, you have minus y into 3, because minus y can this will give you this. Y minus y times this y. But remember this minus, so this will be plus. Minus times plus is minus, and then minus plus 1. Because minus times plus is minus, so minus 1 all over. At this point, I can take out my x, we have x common. I can take out my x to have 2x squared y plus 2y plus 1. Because x times this is this, x times 2y is this, x times 1 is x. So you see I have this. I believe at this point we'll stop. So that is the value for our dy dx. Thank you.